Okay, so we're moving on to our next section, which is going to be on the properties of liquids on there. And you're going to see a lot of the same things between liquids as we did with gases. Remember that liquids can be described as a form of matter. It has a definite volume, but it takes the shape of its container, very similar to that of a gas. But this time it has a definite volume, where the gas did not have a definite volume and it filled the container. The properties of a liquid can be understood by applying, again, the kinetic molecular theory when we start looking at the motion and the arrangement of the molecules and the forces between them. So let's go ahead and start filling in a couple of our notes here. Okay, so let's go ahead and get these notes put in. Remember, it has a definite volume. It takes the shape of the container, and the particles are in constant motion. But again, you got to realize that they are closer together than that of the gases, and the attractive force between the liquid particles are greater or stronger and more effective than that of gases. So pause and get those down, and then go ahead and start back up. So one is, we talked about motion, but let's talk about, again, a fluid. Remember, we talked about a gas was a fluid. A liquid is also a fluid because, again, it has that ability to flow. Now, went ahead and added in an extra word here for us, which is viscosity. Viscosity is related to that ability to flow. And so viscosity is the resistance to flow. So a lot of times when we're talking about viscosity, we'll have different liquids. So maybe like we might have oil, we might have water, we might have syrup, like maple syrup or something that's really thick, and we pour them all at the same time and see which one runs down a board or something faster. That's what we call viscosity, that resistance to flow, where the syrup, the maple syrup, is not going to want to flow very fast. It's going to take a long time for it to come down, where the water or the oil is going to go very quickly. So again, throw viscosity in there as a word also. Now, in terms of density, remember we said that gases have a very, very low density because they have so much empty space. Well, the liquid does not have that empty space as much. It does have some, but not near as much compared to the gas, and therefore it has a lot higher density than that of a gas, again, because those particles are very closer together. And I did put a picture down here below where we're talking about it. So then I talked about compressibility, but that picture there, you've got a gas, and again, it's got a lot of space, which is that even the space that I put there is not relatively compared to what it does. And then you've got your gas that has just a little bit of space in between it. So I put that there because of compressibility. So again, if we took those 5 gas molecules and we tried to pressurize them, to compress them, then we could make them look like we could make them look like that of a liquid closer together and got rid of it. Liquids are not going to be able to be compressed very much, and so we really say that they're incompressible because of the fact there's not enough space in between those particles. Okay, so let's be sure we get those written down, and then we'll continue on. Okay, so I'm running out of room, so we're going to go ahead and finish talking about a couple more of these. And again, we talked about diffusion earlier, of where the 2 gases, the perfume or the cookies, and how they slowly diffuse into the air. On that, well, the same is for liquids. They also diffuse 2 liquids within one another. And I used an example as if you take water. If you had water in one glass and you had some pop in the other, and you just pour them one into the other, they're going to just spontaneously spread one throughout the other. Again, because of the random motion of the particles. So they somewhat by themselves, because of that motion, will make themselves mix together. An example that the book used is, and some of you may have done that as a lab earlier, is if you have water and you put a little drop of food coloring in it, generally it will on its own, especially if the water's just a little bit warm. If your water's too cold, it might not do it as quickly, but it will slowly diffuse through itself. And if you leave it setting long enough, you're going to come back and you're going to have solid green water on that. So that is your diffusion. The next one we're going to talk about is surface tension. And surface tension is a force that pulls the adjacent parts of the liquid surface together, therefore decreasing the surface area to the smallest possible size. So it's going to make it cover the least amount of area because the attractive forces of, again, the molecules. When we're talking about water, we're talking about the hydrogen atoms and the hydrogen bonds pulling on each other, keeping the water molecules together on that, which is one of the reasons why water has the greatest surface tension, a lot greater than most of the other liquids. And we'll talk about an activity. We may do it in class if some of you have not did it before. And just give you an example of the surface tension of water on that. Okay, so go ahead and be sure you have those down. Again, you might leave a little bit more extra space than I did for surface tension because I kind of ran out of room, and then we'll talk about a couple of more words. So our next word is capillary action, and again, I kind of ran out of room there with surface tension, but capillary action is the attraction of the surface of a liquid to the surface of a solid. An example, and you may have noticed that if you take a straw and put it into a liquid, if it's a clear enough liquid that you can see that the water will rise up into the liquid will rise up into the straw higher than the top of where the liquid is. That would be one example on there. The other is the meniscus that is in our graduated cylinder. You could say that that is due to capillary action. That's also has a little bit to do with the next two words that I added in, so please add those in somewhere, which is adhesion and cohesion, and you've probably heard of those words before. So adhesion is when you have dissimilar, two things that are different, which again would be a case of the meniscus, particles that tend to cling to one another. So in terms of the meniscus, it is your water clinging to the glass. And then you've got cohesion, which is when you've got similar properties, two things that are alike that are clinging to one another on that. And those are the words for that page. Be sure you have all of that written down, and then we're going to move on.